Hey, anybody in there? Oh, hey. Um, Today we're going to talk about the Pythagorean theorem and its converse. Converse? What about its Adidas or Nike? Bad dad joke. Bad dad joke. So, the Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So just so we can keep this in mind here, um, these are the legs, right? This is the hypotenuse. So let's do some awesome Pythagorean theorem example problems here. So we want to find x. Do not do this. It's been done. Okay, so let's do the problem. So we know that 6 squared plus 15 squared equals x squared. So what we want to do then at this point is to go ahead and square everything that we need to. And this would be a good time to take out your calculators if you need to. But 6 squared is 36, plus 15 squared is 225, and that's going to be equal to x squared. So, using your calculator, 36 plus 225 comes out to 261. Now, let me point this out. If I ask you to find it to the nearest hundredth or things like that, so let's talk about the different ways we can put our answers on any assessments that we might see. So we're going to take the square root of each side of the equal sign, right? If I can take the square root of the right, and I will take the square root of the left. So when I do that, I find out that the square root of 261 does equal x. Now, is 261 a perfect square? So we're going to figure that out by using our handy dandy calculator here. So square root of 261, and I hit enter, and I do not have a perfect square. So it comes out to 16.15555 repeating. So basically, if I tell you to find it to the nearest hundredth, you write your answers. So we would just leave our answer here. This is not a perfect square, 261, okay? We could go ahead and factor it if we want, but in this case, if I ask you to find to the nearest hundredth, then you would say 16.15, right? This is an approximation, right? It's not an exact answer. This is an exact answer right here, okay? So typically we like to leave things as exact as possible. So leave it as the square root of 261 if we are doing a let's say a homework quiz, or unless I tell you to find it to the nearest hundredths. Let's do another one here. So here I have a leg. This is a leg, right? The hypotenuse is here, right? It's across from the 90-degree angle, the right angle. So I have x squared plus 9 squared equals 11 squared. So x squared plus 81 equals 121. So x squared is equal to 40. So again, we're going to take the square root of each side of the equation, and we end up with x is equal to, the square root of 40 can be factored, and this is something I might ask you to do. So that would be the square root of 4 times the square root of 10, which is 2 square root of 10. Or we might want to say, hey, what is this to the, let's say, the nearest hundredth? So you would take your handy dandy calculator and you would say, what's the square root of 40? And you got 6.32456. And that's only to 5 decimal places there. And we only want to go to the hundredth, so we would say 6. So x is approximately, well, that's terrible looking. Let's erase that because I hate the way it looks. And let's do it as cleanly as we can. X is approximately 6.32. Okay. All right, now a Pythagorean triple. What is that? Well, that is a set of non-zero whole numbers a, b, and c such that a squared plus b squared equals c squared. They come out evenly. So all three of the numbers would come out as even numbers. First one we want to talk about, and you'll notice here, is 3, 4, 5, and then we've got 5, 12, 13, and 8, 15, 17, and then 7, 24, 25. So those are the ratios. If you'll notice here, as we work our way down these columns, we have 6, 8, 10. Well, that's 2 times, right? This is 2 times, and here is 3 times, right? And so you can see here now we have 3x, 4x, 5x. So whatever, how many times a number, so the number, so we end up with a ratio, right? We're simplifying the ratio here. And you'll see this is true for each one of these other ratios here. Yeah, the yellow doesn't quite come out. So as you can see there, like we were talking about. So this is what we want to look at and want to focus on. If we can memorize this, we know we have a Pythagorean triple. 3x, 4x, 5x, 5x, 12x, 13x, 8, 15, 17, 7, 24, 25. Those are the 4 most common ones you're going to see. Now, hey, let's insert some awesome Pythagorean triple example problems here. So we want to use this here, right? So the way I would do this is the first thing I want to look for is a common factor, the greatest common factor between given values, right? So what number goes into both 15 and 12 evenly, and that would be 3. So if I divide 3 in to each of those, well, I end up with 5 here and 4 here. Well, since it's a right triangle, now I know that I have a 3, 4, 5 right triangle. So now I can solve for x by saying 3 times 3 equals 9 is equal to x. Okay? So you're going to multiply the greatest common factor by whatever is missing from the triple. Let's take a look at this one here. Okay? So my 2 numbers are 20 and 48. Go ahead and pause here to figure out exactly what number is the biggest number that goes into 20 and 48. I'll wait. Okay, great, you're back. That is cheesy as all get out, I get that. So anyway, the greatest common factor between these 2 numbers is 4, right? 5 times 4 is 20. 12 times 4 is 48. So the greatest common factor is 4. So now you can divide that out. So this is a 5, right? This would be 5 here. This would be a 12. Well, the triple that works with this is the 5, 12, 13. So remember, 13 now times 4 is going to be equal to x. And so x is going to be equal to 52. Here's another one. We've got 14x and then 50. So greatest common factor between 14 and 50 is 2. So now you go ahead and you divide 2 out. So we end up with 7 here, and this is 50. No, excuse me, 25, right? That divides by 2 is 25. So this is a 7, 24, 25. So 24 times 2 is 48, which is equal to x. Now, the converse of the Pythagorean theorem says this. If the sum of the squares of the lengths of the shortest sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle, okay? But what if they're not equal to it? So if the square of the lengths of the longest side is less than the sum of the squares of the lengths of the other sides, then the triangle is acute, okay? So if a squared plus b squared is greater than c squared, then triangle ABC is an acute triangle. If the square of the length of the longest side of a triangle is more than the sum of the squares of the lengths of the other triangles, then the triangle is obtuse. So if a squared plus b squared is less than c squared, then triangle ABC is an obtuse triangle. Right? If they're equal, it's right. If it's less than, right? If a squared plus b squared is greater than c squared, right? Then you've got acute. And now, if it's less than c squared, it's obtuse. So, and do some awesome converse of the Pythagorean theorem example problems here. Determine whether each set of numbers can be measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Well, 7, 4, and 16. So we're going to take, and we know that, first of all, 7 plus 14 is greater than 16. We're fine. And 16 minus 14 is less than 7, so they were fine with that. All right. So we're going to say 7 squared. We have a triangle. We can make a triangle here, plus 14 squared. And we don't know what that value is, what that's going to be. So we're going to use a question mark, and then 16 squared. So 7 squared is 49. And 14 squared is 196. And 16 squared is 256. So 49 plus 196 is 245. So 245 is less than 256. Since those two are less than, remember what we said, a squared plus b squared. If it's less than c squared, this is an obtuse triangle. Okay, let's try another one. Determine whether the sides can be a triangle, and if so, is it acute, right, or obtuse? Okay, so 9, 40, and 41. Yes, we can tell. 9 plus 40 is greater than 41, and 41 minus 40 is less than 9. So we're going to set this up again. 9 squared plus 40 squared. And we don't know the result of that, so we're going to say question mark 41 squared. So 9 squared is 81 plus 40 squared is 1600. And there's a question mark here. And 41 squared is 1681. So we know that this is equal to 1681, and this is equal to 1681. So we have a right triangle. Here we go. Another one. Oh, wow. This is going to be interesting. So, take my word for it. These are the lengths of a triangle. So these can be a triangle. So we know when we do this, it's going to be 2 square root of 3, and the whole thing's got to be squared, plus 4 square root of 2 squared. And we don't know what this is going to be. And this is, the whole thing is 3 square root of 5 squared. And there's a reason I use parentheses here, because I want to make sure I square everything. So 2 squared is 4, times the square root of 3 squared is 3, plus 4 squared is 16, and square root of 2 squared is 2, and this is how you can do this longhand. And you better be practicing this, because you'll have to do it next year in Algebra 2 with trig. 3 squared is 9. Square root of 5 squared is, oops, no, get rid of that. That's 5. So 4 times 3 is 12, plus 16 times 2 is 32, and 9 times 5, 9 times the square root of 5 is, no, excuse me, oh boy. 9 times 5 is 45. So 12 plus 32 is 44. So 44 is less than 45. So this is, again, obtuse. Take some time, focus on this, guys, and make sure you do the problems that are assigned. Stay healthy. Have a great day.